Hi, hello and welcome to BK'sTechStack. I am BK. Today we are going to learn about defining agentic AI systems. Let us start by defining agentic AI. Think of it as a step beyond standard AI. These systems do not just wait for input, they operate autonomously. They can reason, decide, and act proactively to reach goals in changing environments. It is about moving from simple task execution to intelligent, goal-driven behavior that functions without constant human supervision. To build an agentic workflow, we need specific pillars. First, the AI agent itself, which handles the core logic. We equip it with tools for external data, use prompt engineering to refine its instructions, and finally, integrate it with our existing systems. It is like giving the agent a brain, a set of tools, and a clear path to connect with the real world.
Here is a simple structure for an AI agent in Python. We define a class that holds the AI model and a list of tools. The act function is where the agent would process the goal. By bundling these, we create a reusable template for our agents to handle different complex tasks. To get started, we need the right tools in our environment. I am using a standard command to install our Agentic framework library. Notice how clean the installation is. This package gives us the core functions to build, test, and deploy our agents efficiently. It is crucial to understand the difference between traditional and agentic AI. Traditional systems are rigid, following fixed rules and needing human intervention. Agentic AI, however, is dynamic. It adapts to the environment and manages its own goals, which represents a fundamental shift in how we build intelligent software.
Tools are how agents interact with the outside world. Here, I'm defining a getWeather tool. By using a decorator, I tell the agent, this is a tool you can use when you need data. When the agent reasons that it needs weather info, it calls this function automatically.
Every agentic system follows the sense, plan, act cycle. It starts by sensing data, like reading a user request or checking a database. Then it plans a sequence of steps to solve the request. Finally, it acts by executing those steps. It is a continuous loop that keeps the agent responsive and effective. An agent without memory is just a calculator. Here I am implementing simple list-based memory. By storing previous tasks, the agent can understand context in multi-step workflows. This is the foundation for more complex, long-term memory systems, like vector databases, which store data for the agent to recall later. Not all decisions should be fully autonomous. We use a human-in-the-loop workflow for critical tasks. The agent plans the action, but it stops at a checkpoint for human review. Once the human provides feedback or approval, the agent proceeds. This builds trust and ensures the system remains aligned with our ethical standards. While powerful, agentic AI brings challenges. We face opaque decisions, where we don't always know why the AI chose one action over another. There are also real security risks, especially when agents have tool access. Managing these challenges requires careful auditing and maintaining strong human oversight in our designs. In production, monitoring is our best friend. By tailing the activity log, I can see exactly what the agent is doing in real time. Notice the info logs. They tell us when an agent initiates a search or calls a tool. This visibility is essential for debugging and security.
Should you build a single agent or a multi-agent system? Single agents are perfect for well-defined, focused tasks, but if you have complex, multi-layered problems, you need multi-agent systems. These allow different agents to specialize and collaborate, though they do require more sophisticated coordination and communication protocols.
Ethical design isn't an afterthought. We must bake transparency and safety into our agents. This means regular auditing of performance and, most importantly, having an emergency brake that allows us to halt autonomous actions. Building trust with users depends on our ability to demonstrate that the AI behaves reliably and fairly.
This loop is the heart of an autonomous agent. It keeps running until the goal is achieved. In every iteration, the agent decides on an action, uses a tool, and updates its memory with the results. It's this repetitive cycle that allows the agent to iteratively improve its performance.
To wrap up, remember that deploying an agent is a cycle, not a one-time launch. You define objectives,
build your tools, and test them thoroughly in a sandbox. Once in production, you monitor the logs and feed that data back into the system to improve it. It is all about continuous evolution. Congratulations! You just learned presentation topic. Now it's your turn to apply these skills. Drop a comment below and let me know what you're building. If this helped, smash that like button, subscribe to BK'sTechStack for more weekly tutorials, and share this with someone who needs it. Visit www.BK'sTechStack.com for free resources, exclusive tips, and our community. Next video, we're diving deeper. Don't miss it.